Hello, we are from Group 1, Session 2. So, our group members, we have me, Muhammad Syamin Nasrullah, Mesyarul Nizam.
Me, Limon J. And then our next member is
I am Ahmad Haikal. So, today we will explain how to solve the problem using MATLAB. So, without wasting the time, we start now. Okay, so from the question, we have two problems for the question number one. The voltage across an inductor of inductance L is related to the current flow. Given L equal to 5 H and current I equal to 0.2 exponent power of negative 2t A. Determine the changing rate of voltage at t 5 second, t 10 second, and t 50 second. And then plot a graph showing the voltage variation over time for each given time period on a single paragraph. So for the question number two,
it's about
is about RC integrated circuit is a series connected RC network that produce and output signal which correspond to the mathematical process of integration as shown in figure 1.
this figure one.
So this is the figure 1. So
Evaluate.
the question is evaluate the voltage across the capacitor after
30
30
millisecond.
milliseconds when the RC integrated circuit combined with R equal to 1 kilo ohm and
C
C
equals to 10
equal to 10
microfarad
microfarad and
in, in
V in
12.
12 volt. Assume that the capacitor is initially charged to 3 volt.
So I will discuss about the question number one. So like you can see, this formula is related to dynamic voltage behavior of an inductor. So the formula we will use is this one. And then from the question, give the formula of I current, which is I equal to 0.2 exponent to the power of negative 2ta. So after knowing that, we can differentiate this formula using the theory of exponent differentiation, and then we get this one. So after that we substitute the L equal to 5H into the formula, and then we will get this one lah. And then after we got the formula, we can simply use the equation to find the specific the changing rate of voltage at specific time, like t equal to 5, t equal to 10, and t equal to 15. Okay, now I will explain how we got the answer using the MATLAB. So like you can see here, we declared t as a variable. Then from the question we got this data, which is I equal to 0.2 exponent the power of negative 2t. So this is the current function. Then inductance in the hurry. So you can see here the di dt is equal to differentiate of I and t. So now here is the old L value. So now we want the new one of the L value. So we substitute the L here. Then we got the like we see from the manual calculation, we got this formula. Then we can simply use the formula to find the rate change voltage for the 5 second, 10 second and 50 second. And after we run, we got this answer. Thank you.
Now we move plotting graph for calculation 1. We plot a graph of voltage against time. Next, for x-axis, we using scale increasing 0.1 from 0 to 20. For the y-axis, we using double to make the number become decimal. So now we can plot a graph. We put hold on to hold the system, and next we make a specific point for 5 and 10 and 15. This RO means red color for 5 seconds, and for BO means blue color for the 10 seconds, and GO is a green color for the 15 seconds. This is a title of the graph, and this is a x-axis, and this is a y-axis, and this is a legend for the graph. We put a grid on to make a line on the graph, and put a hold off to end of the graph plotting. Okay, that's all.
Now I will talk about how we're going to solve the problems for question 2. Question 2 is related to RC integrated circuit. So from these questions, we have to use the theory of integrations. So since it's the RC integrated circuits, so the formulas we're going to use is VR equals to 1 over RC's integrate Vn's respect to t with the lower limit zeros to t's. V out is the output voltage in watts. RC is the resistance in ohms. C is the capacitor in farads. T is the time taken in seconds, and Vn is the input voltage in watts. And since these formulas have the limit, so we have to use the theory of definite integrals. Definite integrals is when we integrate this, we have to sub the upper limit and the lower limit. After subbing the upper limit, we have to minus the functions that sub with lower limit, where 0 is the constant that gives the lower limits of integrations. T is the constant that give the upper limit of integration. Fx is the integral of fx. Ft is the values of the integrals at the upper limits x equals to t, and f0 is the value of integrals at the lower limits x equals to zeros. These are the formulas and the theory we're going to use up to solve the questions 2. After knowing the steps, we know how we want to construct instructions for MATLAB. Now, without wasting time, we try to apply to it. This is a MATLAB. This is the code I construct to use for solve the question number 2, and the result the final result I will get 33. These are the running process. First, how I do. This is just a comment, and I first will list out what information I get from the question number 2, and there's the first part I will do is use the FNS is function used for declare the variables. I declare t is a variables, and then line number 9 is I list out the formula I want to use, and int is mean by integrals, and I break it like this. This is the function I want to integrate, and this is the upper limit mean by the lower limit. This is upper limit. This is the times mean by times this device. And line number 12, I start to integrate. I just copy it and paste it. This show the integrals is the result you run after I running the process. This program, this code, it will occur this. It do by the integration, by the substitution with the value of R, C, and V in, and then it will integrate. The final result will appear is 1200 times t. After that, I will calculate the value of 30 minutes per 30 milliseconds. By calculated this value, I will subs is mean by substitutions. These are the function I want to sub, and this is all value I want to replace with this, so I will replace it t, 0.03, and then after I put it, I run out, it will appear the final value is 36. After after replace the t with 0.03, and then I will calculate the voltage across the capacitor. As you know, the initial voltage across the capacitor is start from 3 volt. We want to find 12 volts, so I will use the formula of V finals minus V initials. So this is formulas. These are the calculation we use for this, and minus the value, then we'll find 33. Then I will display to conclude my answers. I use DI space to display, like print out my final answers. So these are the steps I use for, and the codings words I use for calculate for solving question number 2. That's all for me. Thank you.